Hey.
What up? Lecture 4. What makes an element or isotope radioactive?
Oh, by general, it's the ratio of the protons to neutrons in the nucleus determines if it's stable or not. If it's 1-to-1, it's generally pretty good. If I start getting more neutrons than protons, things tend to start to fall apart, and we find out for sure after 84 protons, it's falling apart.
Yeah, definitely. So as elements get heavier, they obviously have more protons and neutrons because we don't count the mass of an electron. There tends to be more neutrons than protons, however.
Yes.
So in the light elements, usually a 1-to-1 ratio. Heavy elements, that's thrown out the door.
Right. So the farther we get from this 1-to-1, the nucleus tends to be more unstable, and the isotope or element will then now become radioactive and hence decay.
Yep.
Decay is a big word.
Decay.
Now there's large, but it's muy importante to our unit.
Yeah. And the simplest, heaviest type of radioactive decay are alpha particles. This is the heaviest form because it has an atomic mass of 4.
It's in Table O.
Table O, that's where you go. Bars. And it has the weakest penetration power.
Because it's so big.
So heavy. It's like a linebacker.
Yeah.
Okay? They can do some serious damage, but they're not going to run 100 yards with the football and a whole opponent team's trying to stop them.
Right.
You can't stop them from falling a foot forward, but you can stop them from running away with it.
Yes.
So they're too heavy and too much of a charge to really go through anything.
Right. Now, beta is a little bit different because beta is basically, like we learned before, an electron.
Yeah.
We know they're small and don't have a lot of mass.
But they do have a charge.
Right. So they have middle of the road ionization radiation power. It's a moderate penetrating power. It'll go through a little bit more stuff than alpha will.
So it'll go through the paper.
But a little bit of aluminum foil or metal would be able to stop it. Metal's dense enough.
Because beta particles have a negative charge, and the negative charges are attracted to positive charges. So that's why they don't go through too much stuff. On their way through, they see, oh, positive charge. Let me got you. And so they can't get through quite as much.
Right. Now, the boogeyman is the gamma.
Yes.
This is like just pure energy.
Yeah.
No mass at all.
No charge either.
So guess what? Nothing in this inside is stopping it. It's not going inside and saying, oh, yay, positive, I got you. No. It's saying, keep going.
And these types of radiation, alpha, beta, and gamma, are traveling at such high speeds that when they hit something, they ionize it by stripping the electrons off of it. And when that happens, that thing that they hit gets damaged. So this type of radiation can cause cellular damage, chromosomal damage, and that would lead to things like radiation sickness, radiation poisoning, potentially long time down the road, cancers, and other sorts of things.
Right. Now, there is a rare one called positron emission. It is on our table, so we're going to include it
there.
Yep. So it's a rare type of emissions that usually trigger
fission reactions, or they're used in medical diagnostics sometimes. I had a PET scan on my knee once. Positron emission tomography. They zapped me with this type of radiation, and they somehow could tell what was in my knee.
Right. So you can see through. It went right through. And
whoa, that's it.
No, 4-minute video on video 4.
You got anything else to say about stability, like just off the cuff?
No, I'm feeling pretty stable right now, actually.
Nice.
Yeah.
Remember, Table O is where you go to find out about your emissions.
Yeah, and you can see in Table O, if you look, like I see helium. I know the mass is below it, so it's got the protons is 2.
Charge is on the bottom.
Right, nuclear charge. You're right. Mass is on top, just like before. So you can see that, the alpha particle is really helium. It says it right there.
Yeah, and the symbols and the names.
And the beta particle is really an electron because it says electron.
When you're running through the business and you're like, positron, let me go check out Table O.
Yeah.
And you'll get the rundown.
Yes.
So that's all, folks. Push a button, make it stop. Push a button, make